I apologize for not being in today, but I have a video, this video that you can watch that will go over a lot of the things that we'll need for today. And the first one is the starter problem. Starter problem is this equation, y equals 2x squared minus 4x minus 5. And we want to put it into vertex form. Remember, vertex form is y equals a times x minus h squared plus k. And that form here is vertex form, but there's two ways to do this. One way we already know, and I want to go over that way first. The way that we already know how to do this is I can take the a value, and that a value is the same as this a value. So since this a value here is 2, this a value is going to be 2. But then I need to find the vertex. And we know that the vertex is always negative b over 2a. So in this case, negative b is going to be positive 4 over 2 times 2, which is also 4, and 4 over 4 is 1. That's the x-coordinate for the vertex. But then to find the y-coordinate for the vertex, we're going to plug 1 back into this equation. For example, 2 times 1 squared is 1, so 2 times 1 is 2. And then minus 4 times 1 is minus 4, and then minus 5. So 2 minus 4 is negative 2. Negative 2 minus 5 is negative 7. So if the vertex is 1, negative 7, then in vertex form it's going to be 2 times the quantity x minus 1 squared, and then minus 7. That is what this is going to look like in vertex form. But I want to show you a different way to get there. And so what I'm going to do is come back over here, and what I'm going to do first is put parentheses around the a term and the b term. And I'm going to get the x squared by itself. And I'm really going to use the process of completing the square. This is going to look like this. We're going to have y equals, if I factor a 2 out, it's going to be x squared minus 2x. And I'm going to leave a space here, and then minus 5, and I'm going to leave a space here. Because what I'm going to do is I'm going to add something here to make this, inside the parentheses here, a perfect square. Just like we were doing on Monday, we're going to take half of the 2, which is 1, and square it, which is 1, which means I'm going to add 1 inside the parentheses. But I didn't really add 1 because this inside the parentheses, I'd have to multiply that by 2. I'm really adding a 2 because 2 times 1 is 2. Well, I don't want to change the value of this side of the equation, so I'm going to subtract 2 over here. So now it's like I added nothing to the equation. I added 2 here, but I subtracted 2 here. And now I'm just going to rewrite this. Y equals 2 times, I can write this whole thing now as x minus 1 squared, and then minus 7. That's the exact same thing that we got over here. Y equals 2 times x minus 1 squared minus 7. I just did it by using a method of completing the square. Let's do that again, and because this is what a lot of your homework is about. And as a matter of fact, you could probably put this in your notes as example number 1. The starter problem is a good example, but let's just go over 2 examples where we're doing this with different equations. Let's say we have y equals x squared minus 10x minus 2. Well, we can do the same thing here. I'm going to put parentheses around the x squared minus 10x. And this time, when I put parentheses around it, I don't have to factor anything out like I did in the starter problem. I don't have to factor a 2 out because there is no value in front of the x squared. It's just 1. So I can go ahead and rewrite this like this. Y equals x squared minus 10x. I'm going to leave a space inside the parentheses. Minus 2, and I'm going to leave a space outside of the parentheses. I just have to remember that whatever I put here, I have to do the opposite of it here because I'm on the same side of the equation. So for example, I'm going to take half of the negative 10, which is negative 5, and square it. That's 25. So if I add 25 inside the parentheses, I'm going to subtract 25 outside of the parentheses. That's different than what we did on Monday, because on Monday we added 25 to the other side of the equation. That balanced the equation out. So here we're just adding something and subtracting something from the same side. Now I can rewrite this like this. This parenthesis is now a perfect square. It's x minus 5 squared, and then minus 27. And that's what this equation, which was in standard form, will look like in vertex form. Let's try one more. This is going to be a little bit different because I'm going to have y equals negative 3 x squared plus 6x plus 1. So we have another equation in standard form, and I want to put it in vertex form. I could do it the other way, the way that we did it at the beginning, where we find the vertex using negative b over 2a and use the same a value, and that's perfectly fine. Just want to show you a different way to do this. And put parentheses around the 3x squared and the 6x, and what I'm going to do next is factor out the negative 3. So it looks like this, negative 3. Then this is just going to be x squared. Negative 3 times negative 2 gives me positive 6x. I'm going to leave a space here. It's going to be plus 1. I'm going to leave a space on the outside. Now I'm going to complete the square inside the set of parentheses. So I'm going to take half of the negative 2, which is negative 1, and square it. Negative 1 squared is positive 1. So I'm adding a 1 inside the parentheses, but I'm really adding negative 3 times 1, which is negative 3. So if I added a negative 3 to this side of the equation, I'm going to add a positive 3 to the same side of the equation. And now I'm just going to rewrite it. Y equals negative 3 times x minus 1 squared plus 4. And now it's in vertex form. So there's a couple examples that you can have in your notes that changes standard form to vertex form. But let's go back because there's probably some questions that you might have over the homework assignment. And one of the things I want you to do is, my phone's ringing. One of the things that I want you to do is, let's go back and look at a question that looks like this. X squared minus 3x equals 28. And I'm just going to go back and solve this equation. Now the goal here is different. We're not rewriting this equation. What we're doing is solving the equation. I'm going to solve this equation by completing the square. And so just like we did before, I'm going to have x squared minus 3x. I'm going to leave a space here, equals 28, and I'm going to leave another space here. What makes this question more difficult is the fact that I have an odd number for my b value. So I can't as easily cut it in half and square it. What I would have to do is cut it in half, which is negative 3 halves, and square that. 3 halves squared is 9/4. And it'd be positive because I'm squaring it, the negative number, so it's positive 9/4. And since I added 9/4 to this side, on the other side of the equation, I'm going to add 9/4 as well. That way I'm adding the same side and it's still equal. This is now a perfect square. This is now a perfect square trinomial. So what I'm going to do is rewrite it as x minus 3 halves squared equals 28 plus 9/4. Well, in order to add those together, I'm going to have to get a common denominator. 28 right now is 28 over 1. So what I'm going to have to do is make sure that it's over 4. And so if I take 28 times, I'm going to have a common denominator of 4. So 1 times 4 is 4. 28 times 4, I believe, is 112. And if I add these together, 9 plus 112 is 121/4. Now that might be a little bit difficult for some of us, but working with fractions is something we're going to have to get used to here. Well, anyway, let's finish this, because now it's the process. It might be a little more difficult because of the fraction, but the process is still the same. I need to get rid of the squared, so I'm going to take the square root of both sides. The left side then will be just x minus 3 halves, and the right side will be plus or minus the square root of 11, or the square root of 121, which is 11, over the square root of 4, which is 2. And if I add 3 halves to both sides, then x will equal a positive 11 plus 3 is 14 over 2, which is 7, or negative 11 over 2 plus 3 halves is 8 over 2, which is, and negative 8 over 2, which is negative 4. And those are my two solutions. Those are my two solutions for that equation. So there's one more example that I would like to do before we move on and have you do your homework assignment. But I'm going to have to get this phone call here in just a second. Hey, Tammy, can I give you a call right back? Tammy?
Yeah.
Okay, thanks. Okay, sorry. The last example that I want to do is one that involves a little bit more than what we just did. I put down example number 4, and this is 2x squared plus x minus 28 equals 0. The reason this is more difficult is because it doesn't have an x squared by itself. We're going to have to get that x squared completely by itself. So here's what I'm going to do. You know what? I'm going to change this one so that we get an example of one that, let me go like this. 2x squared equals 3x minus 4. Again, we have a 2 out in front, so that means that we're going to have to get the x squared by itself. So to do that, I'm going to divide everything by 2 to get the x squared by itself, because you cannot complete the square with a variable in front of the x squared, or with a number in front of the x squared. You've got to get the coefficient of the x squared to be 1. So what I'm going to do is divide everything by 2. So I will have x squared equals 3 halves x minus 2. But then I want the x squared and the x on the same side of the equation. So I'm going to go x squared minus 3 halves x. I'm going to leave a space here. That equals negative 2, and I'm going to leave a space here, because I'm going to want to complete the square on this side of the equation. I'm going to start by taking half of 3 halves, which is 3/4, and squaring that. Well, 3/4 squared is 9/16. So I'm going to add 9/16 to this side, and I'm going to add 9/16 to this side. So this side is now a perfect square. I can write it as x squared minus 3, or x minus 3/4 squared equals, and now I have to add the negative 2 plus the 9/16. Well, negative 2 is the same thing as negative 32/16. Negative 32 plus 9 is negative 23/16. Then I will take the square root of both sides, and when I take the square root of both sides, I'll have x minus 3/4 is equal to plus or minus I radical 23 over 4. Now when I add 3/4 to both sides, I will have x equals 3 over 4 plus or minus I radical 23 over 4. And that is what my answer will look like. I wanted to do this problem because it comes out to be kind of ugly, and so I wanted you to see what that would look like. That is an answer that you might have on your homework assignment. So anyway, the homework assignment then that you can work on at this point is on page 281, and we're going to be doing numbers 28 through 36 even, and then 37, 39, 40, 41, 42, and 50. And I will definitely be back tomorrow. So good luck with that, and I'll also have your quizzes done. Those of you who are not done with your quiz can finish it at this point, and we'll see everybody tomorrow.